Good morning and welcome to our second lesson on operations on functions, where we're going to discuss multiplying functions. Multiplying the functions actually works exactly the same way as adding and subtracting, so I don't think anything that we're about to do is going to come as a surprise in terms of the concept, the notation. There is a notational thing we want to be very, very careful of because it's of an upcoming lesson, and the multiplying can get messy. So it does require you to slow down, pay attention. And so I think just even for practicing purposes, this is something that's worth taking the extra day to do. And so with our notation with multiplying, there we go, there's my n. But then nothing else wrote, so that's kind of weird. All right, I'm gonna try again. The notation for this is f times, and you'll notice I'm being kind of intentional about that, f times g of x, or you can simply write f times g, and the meaning of the notation would be taking f of x and multiplying it by g of x. So you're just going to take the two functions and multiply together. Now I am going to make a little note here. Note, it is important to use a closed circle for your multiplication symbol. Okay, because an x will look like a variable, so you don't really want to use an x for a times symbol in a problem that would have an x, and you don't want your times sign to be bubbly. Okay, so I'll do, you don't want to use that because it'll look like an x like in the problem, okay? And you don't want to use an open circle because that is actually a different operator for a different operation, one that we haven't covered yet. But it's called composition of functions, and so f with an open circle next to the g means to do something different than an f with a closed circle. So if you tend to have bubbly handwriting and you tend to make your time signs like little bubbly open circles, normally that's not an issue, but it is an issue. It is an issue with operations on functions because it's a different symbol. We will cover that operation after we talk about dividing functions and we have our lesson on the domain. And we'll spend a couple days on composition. So just as a heads up for that. So for our example, we are going to be using f of x is equal to 2x squared plus 3x minus 1. And we'll be using g of x is equal to x squared minus 2x minus 4. Now, I am going to demonstrate the strategy that I was taught and the strategy that I prefer, which is to simply use distribution to multiply these. But there are some other strategies, and if this video runs really short, what I'll do at the end of the practice problems is I'll demonstrate some of the other ways that you can structure your multiplication problems, just in the event that you happen to prefer some other ways of doing it. So if you have f of x and g of x, and you are given these instructions to do, well, you know what I'll do in the lesson here is I'll model that as just simply the f times g. Because remember I said you can leave off the of x if you want. And in the video from the last lesson, when I went over the practice problems, I demonstrated like leaving off the of x. But if we did them in class, then you might not have seen that demonstrated. So you can always leave off the of x if the of x bothers you. On the left, we have our f of x, which is 2x squared plus 3x minus 1. And g is x squared minus 2x minus 4. Now, I might have mentioned that I really don't like the acronym FOIL for multiplying binomials. It stands for first, outer, inner, last, and it's intended to help students remember the order that you're multiplying things. I was never taught FOIL. I don't think I was taught FOIL. I was simply taught distribution because that's all FOILing is. It's where you distribute one term and then you distribute the other term. And the reason I like to think of it as distribution is because FOILing only works with binomials, first, outer, inner, last. If you are multiplying two trinomials, now you've got like your first, and maybe you have your outer, and you have your inner and your last, but now you have these like middle terms. Where did they go? Where it happens to the 3x and the 2x. Now, a lot of students will actually use foiling as a synonym for distribution. So they'll say you foil them together, and what they mean by that is distribute, but it's a little bit imprecise in the language there. What we're going to do to multiply these is distribute. Now, I want you to notice that we're multiplying a trinomial times a trinomial. A trinomial has 3 terms. Another trinomial has 3 terms, and 3 times 3 is 9. When we do all of the distribution, we are going to end up with 9 terms, which means this next line down here is going to be very long. Okay, it's going to have 9 terms. If you don't have 9 terms, it means you missed one of the multiplications along the way. So let's go ahead. I'm not going to draw the arrows in because it's just going to get too cluttered to do that. But we're going to take 2x squared and we're going to multiply it or distribute it through the other parentheses. So we're going to do 2x squared times x squared, 2x squared times negative 2x, and 2x squared times negative 4. Not anything you haven't done before, but maybe like a little messier or longer. 2x squared times x squared would be 2x to the 4th. Because when you multiply like bases, you add the exponents, and 2 plus 2 is 4. 2x squared, 2x squared times negative 2x. Well, 2 times negative 2 is negative 4. And x squared times x is x to the 3rd. And then 2x squared times negative 4 is negative 8x squared. And you're done with your first distribution. Second distribution, we're going to take the 3x and we're going to multiply it through. So 3x times x squared, 3x times negative 2x, and 3x times negative 4. I'll actually use a different color when I do this. So 3x times x squared would give me 3x to the 3rd. 3x times negative 2x is negative 6x squared. And 3x times negative 4 is negative 12x. And now you're done with your second distribution. And now we'll do our last distribution, which in this case is going to be a negative 1. We're going to multiply a negative 1 through. So negative 1 times x squared, negative 1 times negative 2x, and negative 1 times negative 4. Negative 1 times x squared is negative x squared. Negative 1 times negative 2x is positive 2x. And negative 1 times negative 4 is positive 4. And you can see when I do that, that each one of those multiplications results in 3 terms, and you have 3 multiplications at 3 terms each, which is what gives you 9. So if I count them 1, 2, 3, 4, 5, 6, 7, 8, 9, that's how I know I haven't left anything out. It is long and it is a lot of writing, but it's not really anything new. You've done these things before. You've distributed before and you've multiplied things with like bases. It's just a matter of getting used to the fact that the problem is longer and that you have to maybe move a little bit slower. You might need to do some scratch work off to the side, depending on how comfortable you are with the multiplication, but it's a doable problem. Just like allow yourself the time to do it. Now we combine like terms, which also is not new. Now this is where I said in the last lesson, it does become beneficial to kind of cross off the things as you're combining them, because you do have a lot of things there and they're kind of scattered around, so it's easy to leave something out. If you have polynomials in standard form and you multiply them from standard form, your highest exponent will be over here on the left and your constant will be over here on the right, and then you'll have like kind of the rest of them all mixed in. So we only have one x to the 4th term. That's 2x to the 4th, and I'll go ahead and I'll cross that off. Now, when it comes to the cubics, I have negative 4x to the 3rd, negative 3x to the 3rd, and it looks like those are the only two I have. So that's going to give me negative 7x to the 3rd, and I'll go ahead and I'll cross those off. X squared, I have negative 8x squared, negative 6x squared, and then just a plain negative 1x squared. So that's going to give me negative 15x squared. And we'll cross those off. Then we have our linear terms, or our x terms. We have negative 12x plus 2x, which is negative 10x. Cross those off. And then we have the constant plus 4. And if you've done everything right, you should cross everything off. I would not expect you to both circle and cross. That is something that I'm doing in the video and something I'll probably do in class as well, to illustrate like what we're doing and to help you follow along as I'm carrying the problem out. But the end result is a little bit messy and chaotic, so I would not necessarily expect you to do that out. Take your time. Take it slow. It's not anything new. You have distributed before. You have multiplied like bases before, and dealt with the exponents. You have combined like terms before. So it's all skills that you've had before. You just need to slow yourself down and give yourself the time to do them. So for your practice, okay, so we'll just do the one example. For your practice, I'm going to actually give you 2 practice problems to do out. And I'll take a second and pause the video so I can write those out. All right, so here they are. I did one in green and one in purple, and I'll talk you through them. And you can pause the video, make sure you copy everything down. So for the first one, f of x is x plus 3, which is nice. And g of x is negative 3x squared plus 3x minus 1. And you're going to be doing f times g of x. For the second one, f of x is x to the third. Okay, I actually wrote it down. I had to fix it in the video as x squared because that's kind of instinctively what you want to do. Notice that there's no x squared in that. So that's x to the third plus 2x plus 1. Note that it's an x to the third. And g of x is x squared minus 3x plus 5. And for the f times g, I left off the of x just as a reminder that you can do that. These are going to take you some time to do. So we will pause the video. I'll give you guys time to work it out. And then what I'll do in this video here is when I go over it, I'll actually demonstrate some of the other techniques for multiplying and hope that I get them right. So, stay tuned if you're watching this at home, and just maybe you'll see some other strategies that you like better than the distribution. Okay, so for this first one, I'm going to model what's called like a vertical strategy. This actually is going to work a lot like, if you were doing like 25 times 4, like we'll do 25 times 14, and where you would multiply like the 4 through, okay, and then multiply, and then you'd add, okay? So one of the advantages of a vertical strategy is it mimics the algorithm and the strategy that you would use when you're multiplying with your numbers like that. It also will not stretch the problem out like as long as distribution does. So we would start this out by taking the positive 3, and we're going to multiply it by everything above it, just like you would in that multiplication problem I had off to the side where you would multiply the 4, and then you kind of multiply along the diagonals. So the negative 1 times 3 is negative 3. So I do this. Then I do 3x times 3, which gives me 9x. And then negative 3x squared times 3, which would be negative 9x squared. And then you'd put like a plus sign in there because that was a positive 9x. And so that's one. And now we'll do the same thing we would do with a regular multiplication problem, is we're going to take this and multiply it. And what you do is just like with multiplication, you often have like that placeholder 0 there. You're going to line up the like terms. So x times negative 1 is negative x, and you line it up with the x in the previous column. 3x times x would be 3x squared, and it's a positive 3x squared, and so you'd line up your x squareds. And then negative 3x squared times x would give me negative 3x to the third, which would be out front. And then just like with a multiplication problem where you would add going down, you will add these going down. And if you've done everything right with the signs, you should come out okay. So you bring down the -3. 9x plus -x would give you 8x. -9x squared plus 3x squared is -6x squared. And that was what, a positive 8x. And then there's nothing to add the -3x cubed to. There's a cat laying on his back on top of the homework here. He looks cute. He really wants to do math too, but he can't because his brain is too small and he can't do numbers. So yeah, he's just going to purr instead. His life is tough. So there you go. So that's like the vertical strategy. I actually learned that from Miss Braswell. If I didn't mention that, I might have mentioned that at the beginning. I learned this from Miss Braswell. It's just one of the ways that she teaches it. One of the advantages is that it doesn't stretch the problem out horizontally quite as long. So with the distribution, you do end up with it like stretched really far across your page. And it can get really, really ugly. And it also mimics the multiplication algorithm that you are more used to, where you multiply each term through and you would like add going down at the end. So there are some advantages to that. Okay, so let's look at the last one here. And this one, we'll use what's called the box method. So a lot of students do like this. And that's where you would do something like this. I'm not totally sure. I think for this, I'm not absolutely sure how this is going to work. But you'll notice that for the first polynomial there, I added in the 0x squared. When you do the box method, if you do it like the way it typically would look where you don't have any missing terms, the like terms should end up on the diagonal, which makes it really easy to combine the like terms. But if I don't put in that x squared, I don't think they would end up on the diagonal. So now, the way the box method works is it looks something like this, where you would do one polynomial across the top of the box and one polynomial going down. So we have the x to the third plus 0x squared plus 2x plus 1, and then x squared minus 3x plus 5 is the other one. And you create a box, and then you will multiply. And the product, so you're going to multiply like whatever's on the left by whatever's on top, and then you'll write the product in that particular box. I actually don't like my box, so I'm going to redo it. Okay, so I just felt like my box was getting a little bit cramped on the right-hand side there. Okay, so to fill in this first box, we're going to do x to the third times x squared, which is going to give us x to the fifth. Remember, when you multiply like bases, you add exponents. Then we do 0x squared times x squared. Well, I love zeros. Like, they're the best thing ever, so that's like 0. 2x times x squared, which is going to give us x to the 2x to the third. And then 1 times x squared, which of course is x squared. And then we go down and we do x to the third times negative 3x. Oh, I've got a cat. No, stop, baby. Why don't you go over there? Okay. Wait, hang on. All right. Where was I? Negative 3x to the fourth. Oh, and this like up here would be 0x to the fourth, because x squared times x squared would give you x to the fourth. Then we have 0x squared times negative 3x, which would give us 0x to the third. Here we have 2x times negative 3x, which would give us negative 6x squared. And 1 times negative 3x, which is negative 3x. All right, last one, x to the third times 5, which would give us 5x to the third. 0x squared times 5, which is 0x squared. The 2x times 5 is 10x. And then 1 times 5 is 5. Now, I know that created like an extra column and you're like, well, wait a minute, that's like a stupid column because everything in it is 0. But here's what creating the extra column did is it arranges your like terms so they're on the diagonals. So you got like x to the 5th up here and there's no other x to the 5th. So you're good to go there. What it does is it puts all your like terms so they're on these diagonals when you go to combine them. So you don't have to hunt for them. If we didn't have that other column there, then the like terms would be a little bit more jumbled in the box. So negative 3x to the 4th plus 0x to the 4th is negative 3x to the 4th. And again, notice that like kind of holding the x to the 3rd enables all the x to the 3rds to be like right on that diagonal. So we have 5x to the 3rd plus 0x to the 3rd plus 2x to the 3rd, which is 7x to the 3rd. 0x squared minus 6x squared plus x squared is negative 5x squared. And then 10x minus 3x is 7x. And then the 5 is by itself in the other corner. So this strategy is a couple of advantages to it. One, it's very, very graphical. It gets very visual. It doesn't involve your eye tracking quite as much as the distribution does. It keeps all of the terms ordered. And so there's like a logical way that they're ordered. If you put in that placeholder, then you'll have this nice arrangement on the diagonals. So you're not having to kind of look all over the place. If you think of this, like we're kind of looking all over the place for the like terms. So it keeps stuff a little bit more organized and serves as a check. You're very unlikely to miss any of the multiplications using it, and it doesn't stretch it out really, really long across the page. So each of these methods has advantages to it. Frankly, I don't care what kind of method you use for multiplying your polynomials as long as you understand the method. Like, I want you to be able to do it. I want you to be able to get it right and understand what you're doing and have some confidence with it. So doesn't make any difference to me. And I think it was worth it in this lesson to actually show a couple of other ways of doing the problems. So you are welcome to pick whatever method you like. And if you're someone who's not my student who's watching this video, do whatever your teacher tells you to do.